Okay, let's do a few more examples of Lewis structures here. So to start with, I've got Cl2, and if you look on your periodic table, you'll find that Cl is in group 7A, so it's got 7 valence electrons. Since I've got 2 of those, I'll do 7 times 2. Gives me 14 valence electrons to work with, doing the counting step. After you've counted, we want to draw the skeleton. I've already got part of that done for you by putting chlorine here. I just need to connect them with a line. Okay, that used 2 valence electrons. Next thing we want to do is take care of the outsiders. Both of these are outside, they're not in the middle, so we're just going to try to make sure that they have 8 valence electrons if possible. So I have 2. I can only use 14. 2, 4, 6, 8, 10, 12, 14. Okay, I used up all 14. Now let's check. 2, 4, 6, 8. That chlorine's happy. 2, 4, 6, 8. That chlorine is also happy. Going on to O2. O2 has 2 oxygens, and oxygen has 6 valence electrons. So that would be 2 times 6 to give us 12. 12 electrons to work with. I have 2 making the skeleton. Now take care of the outsiders. 2, 4, 6, 8, 10, 12. Uh-oh, I've run out. Okay, now there's a couple different ways you can do this. You can think about this, but I want you to recognize that this oxygen is happy. This one doesn't have enough. The way I look at it is they're neighbors. Okay, and this one has an abundance of electrons. This one came up short. So this friendly neighbor is going to share 2 valence electrons. We're going to make a double bond. So we end up with something that looks something like this. Now let's check it. 2, 4, 6, 8. 2, 4, 6, 8. You do double bonds and triple bonds if there are not enough electrons to make every atom in the molecule happy. And you can really only do it with a few different elements. That's carbon, nitrogen, oxygen, and phosphorus. But we didn't really spend a lot of time on that, but just kind of a side note, CNOPs, carbon, nitrogen, oxygen, phosphorus, and sulfur, those are the ones that can form double bonds. Let's look at the next one. Carbon has 4 valence electrons. And then I've got chlorine with 7 each. So carbon 4, chlorine 7. And since I've got 4 of those, I'm going to multiply 4 times 7. So that gives me 7 times 4 is 28. 28 plus 4 is 32. I've got 32 to work with. Start by doing our skeleton. I've got carbon in the middle with 4 chlorines. Connect each chlorine to the central carbon. I just used up 2, 4, 6, 8 electrons, and I've got to get to 32. So that's 8, 10, 12. Remember, we go to the outsiders first. So 2, 4, 6, 8, and then 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and then finally 32. So I've used all of my electrons. What's left is to check and make sure that every atom in the molecule is happy. So carbon has 2, or I'm sorry, let's start with carbon. Here we are, 2, 4, 6, 8. And then each of the chlorines has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. You get the point. All right, let's go on to NH3. NH3, nitrogen has 5. I'll stop looking at the periodic table with it, but you know where to find it. It's just the group number that it's in. 5A is 5 valence electrons. 5 plus, I've got 3 hydrogens, so 3 times hydrogens in group 1. 3 times 1. 5 plus 3 is 8. Okay, start with our skeleton. We've got N in the middle, 3 hydrogens on the outside. Connect each H. That's 2, 4, 6. I still have 2 extra electrons to use. So I start by looking at the outsiders. Since they are hydrogen, they only want 2. This one has 2, this one has 2, that one has 2. They're all happy. So we move on to the middle. Okay, leftovers go on the middle after we've taken care of the outsiders. The last 2 go there. So to get to 8, we have 2, 4, 6, 8. And that's exactly how many nitrogen wants around it. We already said hydrogen is happy because it has 2 valence electrons each. H2O, I have 2 times 1 for hydrogen plus 6 valence electrons for oxygen. 2 plus 6 is 8. 2, 4, 6, 8. Now I just went through the steps a little more quickly, and you'll get to where you can do that too. Did the counting, drew the skeleton. I saw that hydrogen was already satisfied, so I don't put anything else on the outsiders. Then I went to putting the leftovers on the central atom, and then I counted 2, 4, 6, 8 to make oxygen happy, 2 apiece to make hydrogen happy. Let's look at H3O plus. This one's tricky. This is the first positive ion we've done. I want you to remember from our notes on the previous page that a positive ion has fewer electrons. So let's start with 3 hydrogens, so 3 times 1, plus an oxygen, which is 6 valence electrons because it's in group 6A. But since I have fewer electrons, okay, that positive charge tells me I have fewer electrons because it's positive 1, just 1 less, I'm actually going to subtract 1. I'm taking away 1 of those electrons. Alright, so I get 6 plus 3 is 9, minus 1 gives me 8. Now, let's go ahead and draw the Lewis structure. Got 2, 4, 6. Hydrogen only wants 2, so it's already satisfied, but oxygen would like 2 more. And that makes 8. We're done with that. The next thing that's left is to make sure that we draw brackets around it because it was an ion and show its charge, which was positive 1 or just plus. Okay, let's move to the next one. SO3 with a negative 2 charge. Sulfur has 6 plus 3 times 6. And then I have 2 extra electrons because of that negative 2 charge. So I'm going to add 2. So 6 times 3 is 18. It makes 26. If I did my math right there. 26 electrons. Go 2, 4, 6. I've got 20 more to work with. We always start on the outsiders. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and I've got 26, so I put the last 2 on the central atom. Okay, outsiders first, then the central atom. Check. Oxygen, if you count them, each of them has 8. Sulfur also has 8, so they're satisfied and we're done. Now we get to this one. I've got SO3. The difference here is I don't have the negative 2 charge. It's just SO3. So that's 6 plus 3 times 6. So that's going to be 24. 6 times 3 is 18 plus 6 is 24. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then 24. I hope you're using pencil. I'm not, so I'm going to be using some whiteout. But if you look at this, oxygen is happy. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. But sulfur only has 2, 4, 6. We need more electrons, but we ran out. We used all 24. When you do that, remember we can make double bonds. So what I'll do is take 2 of these and make it into a double bond. You could draw arrows and then redraw it, but for now I'm just going to cover up or erase 2 dots and make it into a line instead. Okay, so we have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8 still for that oxygen, but now sulfur has 2, 4, 6, 8. Use double bonds when there's not enough electrons on the central atom. Then finally CO2, 4 plus 2 times 6, that's 12 plus 4, 16, 2, 4, to make our skeleton, 6, 8, 10, 12, 14, 16. I ran out. Oxygen is happy on the outside, but carbon is not. It only has 4 electrons. It wants 8. So what I could do, and this is a little easier to redraw, so I'll just do it this way. I can take 2 electrons and move it down to make a double bond there. 2 electrons here. Move those down to make a double bond there. Now you wouldn't always do that, but in this case we're going to need that because this is only 4 and I need to get to 8. So it would be C with a double bond, oxygen, double bond to the other oxygen, and that is our final structure. We'll do more examples next time.